Experiment. Aim to measure the specific heat capacity of aluminium. Apparatus. Immersion heater, 50 watt, aluminium block, insulation jacket for aluminium. So I'm going to put the aluminium over here. I'll remove the insulation jacket. We'll use that later. So now I need to weigh this. Now the weight is almost 1 kilogram. So I'm going to start by placing a 500 gram weight at the edge over here. I'll move the middle section. 987 grams. We need to use it in kilograms, so let's convert it straight away, which is 0.987. Now we take some paraffin oil and we place it in the small hole, like so. The reason is to allow heat conduction to be more efficient into the thermometer. Now before I put the thermometer in, I'm going to take a quick reading. It says 26 degrees. That will be my initial temperature. So I place this inside here. Over here we have a stopwatch. So I'm going to do both at the same time. Turn on the power supply and the stopwatch. Now what we do is we measure the temperature rise after 5 minutes. Now 5 minutes are up. What we need to do is allow the temperature to settle and record the highest temperature. Now that we've had a look at all of these things, let's do the experiment. We'll start by measuring out the hydrochloric acid. I'll just move this delivery tube. We're going to use just 10 centimeter cube of hydrochloric acid. So I'm going to measure this. Next, I'm going to get my calcium carbonate. We only want 1 spoonful, so we grab some. We take this block to wipe off the excess so we have a nice even amount of calcium carbonate. We get the delivery tube in place so that we're all ready, because the gas is going to come out quite quickly. So let's begin. Get the calcium carbonate, add it to the acid, very quickly put the bung on, and as you can see, we're collecting some gas here. Okay, so the gas has stopped coming out. We'll remove this, take the reading over here, which is roughly 32.2. So this reading needs to be noted down. If you increase the angle of incidence past this critical angle, then you get a phenomenon known as total internal reflection, meaning the light ray is not going to refract into the less dense medium, but just reflect back. Let's have a look at this here now in the studio. So what we're going to do is turn off the lights. Let's turn on the ray box. Now, when I place this glass block here, you will notice that as I turn it and increase the angle of incidence, so I'm turning it, this is my angle of incidence between the normal and the incident ray, and over here is my refracted light ray. So as I increase my angle of incidence, my refracted ray increases. If we keep increasing it, suddenly what we get is the light ray moves along the boundary. So we've hit the critical angle, and if we increase the angle of incidence anymore, like so, nothing comes out on this side. There is no refraction, but the light ray is totally internally reflected. It comes out and bounces back this way.